Hello everyone. Today we're going to learn about something called the square root property and how it is useful when we are trying to solve certain types of equations. I'm going to abbreviate it as SRP later on. So, if we have an equation like this one here, says a squared equals b squared, then one technique we can use in order to solve it is something called the square root property, which allows us to take the square root of both sides of this equation. This is useful in certain types of situations, and we'll see the best places for it. So when we take the square root property, when we take the square root of both sides, that means we're taking the square root of a squared, and that's a. We're taking the square root of b squared, and this is where something can get a little tricky, but the answer here is going to be plus or minus b. Let's figure out why. Let's move to number 2. Number 2 is an equation that says x squared equals 25. Now, how do we solve this? Well, we can ask ourselves what this equation is asking us, which is what number fits and works and maintains balance into this equation. If we plug in 5, then we're going to get 5 squared, which is 25, and that means the left side and the right side match up. But what if we plug in negative 5, like so, with parentheses? What we saw was this means that negative 5 times negative 5 is equal to a positive 25. Negative times a negative is a positive. That means this also maintains that balance. So this particular problem has two answers, both positive and negative 5, usually, sometimes, actually not usually, but sometimes written as plus or minus 5, like this. So when you evaluate a square root, and a square root's given to you, like this one, we're evaluating the square root of 25. That answer is only 5. That's called the principal square root. When we are introducing the square root ourselves, like using the square root property in order to solve an equation, this is where we have to consider both positive and negative square roots of that number. So when taking the square root of both sides of an equation, remember to take the plus or minus of the answer. X squared minus 49 is a quadratic equation that can be solved by factoring, difference of perfect squares. X plus 7 and x minus 7. X plus 7 equals 0, and then x minus 7 equals 0 is how the square root property, the zero product rule follows that. And then we can solve each of these equations and get x equals negative 7, and then x equals positive 7. These are the two answers, which again, if we take 7 to the second power, that becomes 49 minus 49, which is 0. If we take negative 7 and raise that to the second power, that also becomes a positive 49, and then 49 minus 49 is equal to 0. So again, these two answers both work in this equation. If we were to solve this a different way, instead of factoring but adding 49 to both sides, and then getting this equation where we can utilize the square root of both sides, the square root property, that means one side, the square root of x squared, is going to be x, and the other side, the square root of 49, is going to be positive and negative 7. Please do not forget that negative. That is very important. It is one of the answers. So let's revisit the square root property, which says this. If a squared equals b squared, then when we take the square root of both sides, we get a on the left side plus or minus b on the right-hand side. So let's use what we looked at with the zero product rule, which was instead of a as a factor, what if it was a binomial, like x minus a to the second power? And that's what we have here. If this factor is raised to the second power, that means we can still take the square root of the entire piece. You're taking the square root of the left side and the right side, and then you're getting x minus a, and then plus or minus b. Well, since x minus a is equal to these two answers, that means we can branch them off into two separate equations, x minus a equals b, x minus a equals negative b, and solve each of them. X is equal to b plus a, x is equal to negative b plus a. We get two answers. This is not the same as the zero product rule. The zero product rule means that this is set equal to 0. And then that means each factor is equal to 0. This is the result of x minus a being equal to two different answers, positive b and negative b. So this is useful in very specific scenarios. Usually equations where x squared is by itself. This is useful. Something like x squared equals 100. Or even something like x minus 5 to the second power equals 10 or 25 or something like that. Like this. X minus 5 to the second power equals 81. If we solve this by factoring, that means we have to expand x minus 5 times x minus 5 to get x squared minus 5x plus 25. That's through the use of FOIL. And then we can combine like terms right here. X squared minus 10x plus 25 equals 81. Set this equal to 0. Subtract 81 from both sides. X squared minus 10x minus 56 equals 0. And then we can factor this by the AC method. These are all the factors, not all of them, but these are most of the factors of 56. 56 has a decent number of factors. But positive 4 and negative 14 is going to add up to this negative 10 that we're looking for. Branch this off into two equations. Factor it first. X plus 4, x minus 14. And then the zero product rule means that we can solve x plus 4 equals 0 to get x equals negative 4. X minus 14 equals 0 to get x equals positive 14. And this is how we would solve this by factoring. Again, first expansion, setting equal to 0, and then factoring, in this case with the AC method. Now let's take a look at the same problem solved with the square root property. X minus 5 to the second power equals 81. If we take the square root of both sides, and again, because x minus 5 is raised to the second power, that means the result is just x minus 5. I'll rewrite this again. X minus 5 to the second. We're going to take the square root, and that means we've got to take the square root of the other side as well, which is 81, and that result is positive or negative 9. So this means x minus 5 is equal to 9. And solving this equation, x is equal to 14. X minus 5 is also equal to negative 9, and adding 5 to solve this equation means that x is equal to negative 4. Same answer that we got above. I'll admit, much faster. Let's take a look at something a little more complicated, but only because there's fractions, not because we're utilizing anything different. Again, once you see this kind of format, this is tailor-made for a square root property kind of problem. X minus 1 over 3 is nestled inside these parentheses raised to the second power. So that means if we take the square root of this side and the square root of the right side, we're left with x minus 1 over 3 alone. And on the other side, a positive or negative radical 5 over 9. A fraction inside a radical is not simplified, so that means we can separate this into two separate radicals. And since the square root of 9 is equal to a whole number, that means x minus 3 is equal to positive or negative radical 5 over 3. We can separate this into two separate equations. X minus 1 over 3 equals radical 5 over 3. X minus 1 over 3 equals negative radical 5 over 3. And we can solve each of these equations by adding 1 over 3 to both sides. Thankfully, there's a common denominator, so we do not have to adjust anything. We simply can just put this together. 1 over 3 plus radical 5 over 3 into one fraction, and 1 over 3 minus radical 5 over 3 into another answer. A lot of times you will see this combined. And this will be something you'll be used to seeing once we get into the next topic. So let's look at x squared plus 6x minus 2 equals 0. This quadratic is not factorable. There is nothing that multiplies to negative 2, but also adds up to a positive 6. So our present method of solving quadratic equations by either factoring or using the square root property, neither of them are useful right now. So let's go through a process called completing the square. Completing the square is a technique that we can use for any quadratic equation, but this will allow us to solve the quadratic equations that are not factorable, which is why this is going to be necessary. The first step in completing the square is to make sure that a is equal to 1. Here, a is equal to 1, b is equal to 6, and c is equal to negative 2. So if a is already equal to 1, that means the first step is done. We don't have to worry about it. But it is something we do have to be aware of if and when x squared has a coefficient of another number. So it's done. Great. The next step is to take the constant value and move it to the other side. That means adding 2 to both sides. So our equation becomes x squared plus 6x equals 2. When you're factoring, you want to make sure it's set equal to 0. But with completing the square, that's not necessary. Actually, it's going to be the opposite of necessary. The next step, this is where things get possibly confusing, so let's go into it. We want to fill in a new constant value. That means we still want to make this a trinomial, but we want to add in our own number. If we add in the number 10, for instance, we're going to have to add it to both sides. Anything you add to one side of an equation, you have to add or subtract it to the other. In this case, we're only doing addition because of the way it works out. We want to make this thing factorable, right? So we want to fill in a number that will make this factorable, but not just factorable, but factorable into a perfect square trinomial. I'll tell you what that means. X squared plus 6x plus 5 is a factorable quadratic. Factors into x plus 5 times x plus 1. X squared plus 6x minus 40 factors into x plus 10 and x minus 4. These, if we filled in a plus 5 here, that would make this factorable. If we filled in a minus 40, that would make this factorable. But again, being only factorable is not good enough. We want it to be factorable into a perfect square trinomial. And the only thing that's going to achieve that here is a positive 9. Because x squared plus 6x plus 9 factors into two binomials that are the same, x plus 3 times x plus 3. That means x plus 3 to the second power. I hope this looks familiar based on what we talked about earlier. So how are we going to find this magical number? We're going to follow this step right here, which is to take b, then divide it by 2, and then raise it to the second power. So since b is equal to 6, that means 6 divided by 2, which is 3, raised to the second power, which is 9. And we have to add 9 to both sides. So the left side will factor. Again, it's not just factorable, but it's factorable into a perfect square. That's going to be, in this case, x plus 3 to the second power. And why 3? Because that is this b value 6 divided by 2. The other side, we're just going to add these together, 2 plus 9. And that brings us to x plus 3 to the second power equals 11. Now, we can solve this using the square root property. Because again, what we're looking for is this, a binomial raised to the second power. So when we take the square root of it, it comes out cleanly. The other side, if it doesn't come out cleanly, so be it. That is the way things go. So x plus 3 equals radical 11. X plus 3 equals negative radical 11. Solve each equation. Negative 3 plus radical 11, negative 3 minus radical 11 is our two answers. Let's do another together. X squared plus 8x plus 52. If it's factorable, I suggest you factor. It's going to be faster and easier, but this one is not factorable. So let's move negative 52 to the other side. Let's create this equation here. Then let's figure out b, which is 8, divided by 2, raised to the second power. 4 to the second power is equal to 16. So that means x squared plus 8x plus 16 equals negative 52 plus 16. Again, this 16 has to be added to both sides of the equation. X squared plus 8x plus 16 factors because 8 divided by 2 is equal to 4. That means it factors into x plus 4 to the second power. Negative 52 plus 16 is negative 36. Let's take the square root of both sides. X plus 4 is equal to the square root of negative 36. X plus 4 is equal to negative the square root of negative 36. The square root of negative 36, as we studied with complex numbers, this is equal to 6i. So our answers are negative 4 plus 6i, negative 4 minus 6i. This one should be x equals. And that is completing the square. Do the companion worksheet. Ask me any questions in class, but we will look at the quadratic formula, which is a direct result of completing the square. Thank you.